Hello everyone. Today we are going to see about the filtering long duration sequence. For example, if the input sequence x of n is of very long duration and the impulse response h of n is given, and if we need to perform the linear convolution, it is very difficult to store all the data before performing convolution. So what we are going to do is we are dividing, that is the long duration sequence, into small sequences and perform the convolution, and at last we are combining all the outputs and we are getting the desired output sequences. For this filtering, we are having two methods. One is overlap save method and another one is overlap add method. So today we are going to see about this overlap save method. The question is, find the output y of n of the filter whose impulse response h of n is equal to 1, 1, 1 and the input sequence x of n is equal to 3, minus 1, 0, 1, 3, 2, 0, 1, 2, 1 using overlap save method. Now, solution. First step, we need to find the length of y of n, that is the output sequence. So let the length of the input sequence x of n is equal to capital L, which is equal to 3, minus 1, 0, 1, 3, 2, 0, 1, 2, 1. So we have the length to be 10. That is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So let the length of input sequence x of n is equal to L is equal to 10. Now, let the length of the impulse response h of n is equal to m. H of n is given as 1, 1, 1, which is 3. So m is equal to 3. And now the length of the output sequence y of n is given as capital N is equal to L plus m minus 1, which is equal to 10 plus 3 minus 1, which is equal to 12. So the length of our output sequence y of n should be equal to 12. Now, the next step is to find the new impulse response h1 of n. So let the length of new h1 of n is given as h1 of n is equal to m1. Okay, that is the new impulse response is represented as h1 of n and its length is m1. So how we'll find h1 of n? h1 of n is equal to h of n, comma, m minus 1 zeros. That is h of n, comma, m value is 3. So 3 minus 1 zeros. So h of n, comma, 3 minus 1 is equal to 2. So 2 zeros you have to add. So h1 of n is equal to, what is the h of 1's value, which is equal to 1, 1, 1. So substitute h of n to be 1, 1, 1, comma, 2 zeros you have to add, that is 0, 0. So hence the length of h1 of n is represented as m1, which is equal to 5. This is very important step. So here what we are going to do is we are dividing that long duration sequence into smaller sequences of length m1. So x of n is divided into smaller sequence x1 as x1 of n, x2 of n and x3 of n, similarly till the duration ends, and the length of each sequences should be of length m1, which is equal to 5 in our problem. So what is x1 of n? x1 of n is equal to m minus 1 zeros, comma, L data. So this x1 of n's length should be 5. So m value is 3. So 3 minus 1 zeros is 2 zeros you have to add, and you have to take the first 3 data from x of n. Okay, and x2 of n is equal to m minus 1 previous data from x1 of n. That is 2 data from x1 of n you have to take, and the remaining 3 data from the x of n. And x3 of n is equal to m minus 1 previous values of x2 of n, and the remaining 3 data from x1 of n. So likewise, you have to form x1 of n, x2 of n and x3 of n. So we'll go to the problem. So x1 of n is equal to 3 minus 1 zeros, that is m minus 1 zeros, comma, L data. So 3 minus 1 is 2 zeros, comma, L data. That is, you have to take 3 data. That is 3, comma, minus 1, comma, 0. So 0, 0, 3, minus 1, 0. Now what is x2 of n? x2 of n is equal to m minus 1 previous data. So m minus 1 is 3 minus 1, which is 2 data from the previous x1 of n. The last 2 values from x1 of n is taken and the remaining 3 data is taken from x1 of n, that is x of n. That is already for x1 of n we have taken 3, minus 1, 0. And now what we are going to do? We are going to take the next 3 data, which is 1, 3, 2. So x2 of n is equal to minus 1, 0, 1, 3, 2. And what is x3 of n? x3 of n is the last 2 data from x2 of n. That is the previous x2 of n. So the last 2 data is 3, 2 is taken from x2 of n and the remaining 3 data from x of n. The remaining 3 data means say already 3, minus 1 and 0 has been taken for x1 of n and for x2 of n we have taken 1, 3 and 2 and for x3 of n we have to take 0, 1 and 2. Okay, now x3 of n is equal to 3, 2, 0, 1, 0 and x4 of n is equal to the last 2 data from x3 of n. That is 1, 2 is taken from x3 of n and the remaining only 1 data, which is the last one. This has to be taken for x4 of n. So here we are having x4 of n is equal to 1, 2, 1. But here our length is 3. But for this convolution, we need all the input sequences x1 of n, x2 of n, x3 of n, x4 of n should be of length 5. So what we need to do is we are adding zeros at the end of the sequence, which is called zero padding. So x4 of n will be 1, 2, 1, 0, 0. Now step 4. So we have got the input sequences x1 of n, x2 of n, x3 of n and x4 of n. So that we have 4 output sequences, that is y1 of n, y2 of n, y3 of n and y4 of n. So how to calculate y1 of n? So y1 of n is equal to x1 of n circular convolution of h1 of n. So this is the symbol for we are using for circular convolution. So x1 of n we have got to be 0, 0, 3, minus 1, 0. So 0, 0, 3, minus 1, 0, circular convolution of h1 of n value is 1, 1, 1, 0, 0. Now, so how we will write? So first write all these 5 elements like in the column wise you have to write, that is 0, 0, 0, 0, 3, minus 1 and 0. So the last element goes to the next row's first element. Okay, so this 0 is taken here and this 0 is taken here and this 0 comes here and 3 comes here and minus 1 comes here. Now this minus 1 goes to the next column's first element. Okay, and for the second element you have to take from the previous column's first element. So 0 comes here, again 0 comes here, 0 comes here and 3 comes here. Now this 3 is taken to the next column's first element. Now this first element goes here, minus 1 goes here, 0 goes here and 0 goes here and 0 comes to the last element. Now this 0 is taken to the next column's first element. So 3 comes here, minus 1 comes here, 0 comes here and here 0 comes here. Now, so totally we have got 5 by 5 matrix. Now it is convoluted with h1 of n, that is 1, 1, 1, 0, 0. Now what we need to do is we are doing multiplication, that is row by column. So the first row is multiplied by this column. Okay, so the first element is multiplied by the first element in this column. The second element of this row is multiplied by the second element of this column. And the third element of this row is multiplied by the third element of the column. And fourth element of this row is multiplied by the fourth element of the column. And fifth element of this row is multiplied by this fifth element of this column. So we'll see 0 into 1 plus 0 into 1 minus 1 into 1 plus 3 into 0 plus 0 into 0. This is for first row. And for second row, it is 0 into 1 plus 0 into 1 plus 0 into 1 minus 1 into 0 plus 3 into 0. Now, for the third row, 3 into 1 plus 0 into 1 plus 1 into 0 plus 0 into 0 minus 1 into 0. And fourth row, minus 1 into 1 plus 3 into 1 plus 0 into 1 plus 0 into 0 plus 0 into 0. Fourth, that is fifth row, 0 into 1 minus 1 into 1 plus 3 into 1 plus 0 into 0 plus 0 into 0. So we have got 0 plus 0 minus 1 plus 0 plus 0. Second row, 0 plus 0 plus 0 minus 1 plus 0. Third row, 3 plus 0 plus 0 plus 0 plus 0. Fourth row, minus 1 plus 3 plus 0 plus 0 plus 0. Fifth row, 0 minus 1 plus 3 plus 0 plus 0. So when we add, we will be getting minus 1, 0, 3, 2 and 2. So y1 of n is equal to minus 1, 0, 3, 2, 2. Now, your y2 of n is equal to x2 of n circular convolution of h1 of n. So we have got x2 of n to be minus 1, 0, 1, 3, 2 circular convolution of 1, 1, 1, 0, 0. So like similarly, so what we have done for y1 of n, the same thing we have to repeat here, the same procedure. So first write this elements in the column wise, that is the minus 1, 0, 1, 3, 2. Now, this 2 is the last, that is the first column's last element is taken to the next column's first element. And now this minus 1 comes here, 0 comes here, 1 comes here, and 3 comes here. So this 3 is taken to the next row, that is the next column's first element. And this 2 comes here, minus 1 is coming here, and 0 is written here, and 1 is written here. This 1 is taken to the next column's first element. So 3 comes here, 2 comes here, this minus 1 is written here, and 0 is written here. And 0 is taken to the last column's first element, and 1 is written here, and 3 is written here, 2, minus 1. Circular convolution of 1, 1, 1, 0, 0. Now, this row by column. So, row by column means minus 1 into 1, plus 2 into 1, plus 3 into 1. So, I have not taken the other two multiplications because anything into 0 is 0. So, I have multiplied the first 3 elements with this 3 elements. Okay. And the second row, 0 into 1, minus 1 into 1, plus 2 into 1. Third row, 1 into 1, plus 0 into 1, plus minus 1 into 1. The fourth row, 3 into 1, plus 1 into 1, plus 0 into 1. Fifth row, 2 into 1, plus 3 into 1, plus 1 into 1. So we have got minus 1 plus 2 plus 3, 0 minus 1 plus 2, 1 plus 0 minus 1, 3 plus 1 minus 0, 2 plus 3 plus 1. So I have got 4, 1, 0, 4, 6. So I have got y2 of n. And similarly, we have to do for y3 of n, which is equal to x3 of n, circular convolution of h1 of n. So x3 of n is equal to 3, 2, 0, 1, 2, circular convolution of 1, 1, 1, 0, 0. So first we need to write these elements in the column by. So 3, 2, 0, 1, 2. This 2 goes here. So 2, 3, 2, 0, 1. And this one goes here. So 1, 2, 3, 2, 0. And this 0 goes to the next column's first element. So again 1, 2, 3, 2. Again 2 goes here. 0, 1, 2, 3. It is circular convoluted with 1, 1, 1, 0, 0. Now row by column multiplication. So 3 into 1 plus 2 into 1 plus 1 into 1 for the first row. And the for second row, 2 into 1 plus 3 into 1 plus 2 into 1 for the second row. And for the third row, 0 into 1 plus 2 into 1 plus 3 into 1. And for the fourth row, 1 into 1 plus 0 into 1 plus 2 into 1. And for the fifth row, 2 into 1 plus 1 into 1 plus 0 into 1. So I've got 6, 7, 5, 3, 3 to be y3 of n. And y4 of n is equal to x4 of n, circular convolution of h1 of n, which is equal to 1, 2, 1, 0, 0, circular convolution of 1, 1, 1, 0, 0. So what we have to do is we have to write this in the column by. So 1, 2, 1, 0, 0. The next one, 0, 1, 2, 1, 0. The next 0, 0, 1, 2, 1. Again 1 goes here. 0, 0, 1, 2. So this 2 goes here. 1, 0, 0, 1. So we have got 5 by 5 matrix and 1, 1, 1, 0, 0. Multiply. So 1 into 1 plus 0 into 1 plus 0 into 1. Second row, 2 into 1 plus 1 into 1 plus 0 into 1. Third row, 1 into 1 plus 2 into 1 plus 1 into 1. Fourth row, 0 into 1 plus 1 into 1 plus 2 into 1. And fifth row, 0 into 1 plus 0 into 1 plus 1 into 1. So we have got 1, 3, 4, 3, 1 to be y4 of n. At last, this is the step 5 where we have to combine all the output sequences we have derived so far. That is y1 of n, y2 of n, y3 of n, y4 of n. So from this, we will be getting the desired output sequence y1, y of n. So y1 of n is minus 1, 0, 3, 2, 2. And y2 of n to be 4, 1, 0, 4, 6. y3 of n is equal to 6, 7, 5, 3, 3. And y4 of n is equal to 1, 3, 4, 3, 3. So what we have to do is we have to discard the first m minus 1 values. So m value is 3. So 3 minus 1 is 2. The first 2 values from each output sequence has to be discarded, that is eliminated, and the remaining data has to be taken. So here minus 1 and 0 are the first 2 elements of y1 of n, and this 4 and 1 are the first 2 elements of y2 of n, and 6 and 7 are the first 2 elements of y3 of n, and 1 and 3 are the first 2 elements of y4 of n. So what you have to do is you have to write all the output sequence y1 of n till y4 of n, and from this you have to eliminate or discard the first 2 values from each output sequences, and you have to consider only the remaining values. So y1 of n is equal to 3, 2, 2, 0, 4, 6, 5, 3, 3, 4, 3, 1. So this is the output sequence we have derived. And the length of the output sequence, which is equal to capital N, which is equal to 12. So we have seen this overlap save method. Thank you so much.